Here's a quick video on how to remember the divisibility rules of some of the basic numbers. Let's start with the basics. The divisibility rule of 2, extremely easy. The number has to be even. That means the units place digit must be 0, 2, 4, 6 or 8. The divisibility rule of 3, the sum of all the digits when you keep on adding them must add up to either 3, 6 or 9. So for example, if I have a number, let us say 6561, then 6 plus 5, 11 plus 6, 17 plus 1, sum of the digits is 18, 1 plus 8, the sum of the digits is 9. One of the three magic digits. So this number 6561 is definitely divisible by 3. What is the divisibility rule for 4? Well, the divisibility rule of 4 is you check just the last two digits of the number, and if the last two digits is a number which is divisible by 4, then the entire number is divisible by 4. For example, 37,228. Is it divisible by 4? I just check the last two numbers. If 28 is divisible by 4, which it is, then 37,228 is entirely divisible by 4. Okay, now let's take a look at the next one. The divisibility rule of 5. Well, the last digit of the number in question must either be 0 or 5. That's it. If a number ends in 0 or 5, it is definitely divisible by 5. The divisibility rule of 6 is the divisibility rules of both 2 and 3, which means if the number is even and the sum of the digits is 3, 6 or 9, then and only then the given number will be divisible by 6. Moving ahead, let's take a look at the divisibility rule of 8. The last three digits of the number is what is to be checked. If those three numbers form a number divisible by 8, then the entire number is divisible by 8. So 2,75,148. I check 148. Is 148 divisible by 8? Well, 148, 8 ones are 8, but 64, 4 is the remainder, not divisible by 8, then the entire number is definitely not divisible by 8. Well, let's move on. Divisibility rule of 9. The sum of all digits must add up to 9. Just like 3. In this case, you keep on adding the digits till you end up a single digit. If that single digit is 9, the number is divisible by 9. So let's take 4 crore 30 lakh 46,721. Is this divisible by 9? 4 plus 3, 7 plus 0, 7 plus 4, 11 plus 6, 17 plus 7, 24 plus 2, 26 plus 1, 27, 2 plus 7, 9. Yes. As we end up with 9, the entire number is definitely divisible by 9. The divisibility rule of 10 is definitely an easy one. For 10, the units place digit, the last digit on the right must be a 0. If a number ends with 0, it is divisible by 10. As easy as that. Divisibility rule of 11. Now this is slightly long but easy to solve. Let's take an example, 14,641. We add up the numbers in the odd places. 1 plus 6 plus 1, 8. We add up all the numbers in the even places. 4 plus 4, 8. We take the difference. If the difference is either 0 or a multiple of 11, then the entire number is divisible by 11. In this case, because the difference is 0, 14,641 is definitely divisible by 11. Let's take another example to understand the divisibility rule of 11. Let's take the number 1596532. So odd places 1 plus 9, 10, 10 plus 5, 15, 15 plus 2, 17. 5 plus 6, 11, 11 plus 3 is 14. The difference is 3, not 0 or a multiple of 11. So this number is definitely not divisible by 11. But supposing I add one more digit, right? For this number, let's slightly change this number and put a 3 at the end. Then 1 plus 9, 10 plus 5, 15 plus 2, 17. 5 plus 6, 11 plus 3, 14 plus 3, 17. Now the difference is 0. So this number is definitely divisible by 11, and that's the divisibility rule of 11. Let's take a look at one more simple divisibility rule, and that is for the number 12. So 12 is written as 3 multiplied by 4. So 3, if it satisfies the divisibility rule, and 4, if the number satisfies the divisibility rule, then the number is divisible by 12. I repeat, to check whether a number is divisible by 12 or not, it must satisfy the rule of 3, that is, the number must be divisible by 3. Also, it must be divisible by 4. For 3, sum of the digits 3, 6, 9. For 4, last two digits form a number divisible by 4. If both the rules are satisfied, then the number is divisible by 12. Why do we not take it as 2 into 6? Because a number may satisfy both and yet not be a multiple of 12. For example, 18. 18 is divisible by 2 and 6, but not by 12. For that, you need to understand that the numbers that we split into must be co-prime numbers. What are co-prime numbers? Numbers whose highest common factor is 1. 2 and 6 are not co-prime. HCF is 2. But 3 and 4 are co-primes because HCF is 1. So we split the larger composite number into two co-prime factors and use the divisibility rule of the co-prime factors to check whether the number is divisible by the given composite number or not. So those are the fundamental divisibility rules which are absolutely essential to remember for cracking so many questions in different entrance examinations. If you like this video, do like, share and subscribe, and drop a comment on which topic you would like me to make a video next. Till then, all the best.